Hey friends, welcome to Nina's Notes 133. I wrote this newsletter on a flight to Berlin, my former home. I returned to a flat which I called my home for most of 2022. The flat where I actually started Nina's Notes. Arriving felt like going back in time. I remember the feelings of letting go of one project, letting go of my company, Mamito, and not knowing what would come next. This newsletter was my anchor into learning, self-discovery, and finding my voice. Now I face another end of one chapter and the beginning of a new one. It's fitting to be back where the journey began, sitting in the same space, but as a different person. The circle closes yet opens again. This cycle of endings and beginnings reminded me of today's topic, the profound brain states that are induced by 5-MeO DMT. Just as this substance can dissolve boundaries and create new neural connections, life's transitions offer us the chance to see ourselves and our place in the world differently. As I settle back into Berlin in this space with new eyes, I invite you to explore how our brains navigate profound change, both the kind facilitated by powerful substances and the kind that comes from life's natural transitions. So, what happens to your brain on 5-MeO DMT? I've always been fascinated by altered states of consciousness and how a tiny molecule can completely transform our perception of reality. 5-MeO DMT is particularly intriguing because it creates what researchers call a dissociative state of arousal. This is a fancy way of saying that you feel like your consciousness disconnects from your body. But here's what really caught my attention. What does that look like in the brain? First, let's talk about the different states that your brain can be in. When you're awake, your brain shows fast, low amplitude waves on an EEG. That's a device that measures brain activity. During deep sleep, called NREM sleep, your brain shows slow waves and spindles. During deep sleep, REM sleep, your brain activity looks more like you are when you're awake, even though you're deeply asleep and your muscles are completely relaxed. We also see a variety of mixed, hybrid, and distinct features of waking and sleep. For example, sleep-like slow waves on an EEG have been observed in awake animals after sleep deprivation, or in patients who have experienced a stroke. So, where does 5-MeO DMT fit into this picture? This is where things get weird. When researchers gave mice 5-MeO DMT, they discovered something unexpected. The mice were clearly awake, moving around with dilated pupils, but their brains were showing slow waves typically seen in deep sleep. This created what scientists call the dissociated state of arousal. Imagine being wide awake, but having your brain act like it's in deep sleep. That's exactly what's happening. The researchers found that pupils dilated 75%, while the brain showed these sleep-like slow waves. Normally, dilated pupils means high arousal and increased brain activity. But here, the opposite was happening in parts of the brain. So what does this mean for humans? When researchers studied DMT, a similar compound to 5-MeO DMT, in humans, they found equally fascinating results. Chris Timmerman, a psychedelics researcher at Imperial College London, measured brain activity in an EEG in people who received DMT intravenously, and he published the results in Nature Scientific Reports in 2019. Timmerman's team discovered that alpha waves, the brain's main rhythm when awake, dramatically decreased, and theta waves, these are associated with dreaming, temporarily increased, and overall brain activity became more chaotic and unpredictable. These effects are the opposite of what is to be seen in states of reduced consciousness, such as in deep sleep or under general anesthesia. Chris Timmerman quotes, "The changes in brain activity that accompany DMT are slightly different from what we see with other psychedelics, such as psilocybin or LSD, where we see mainly only reductions in brainwaves." Timmerman describes the phenomenon observed as, "Here we saw an emergent rhythm that was present during the most intense part of the experience, suggesting an emerging order amidst the otherwise chaotic patterns of brain activity." Overall, people in the experiment described the experience as like dreaming, but with your eyes open. These slow brainwaves might be the key to why psychedelics have therapeutic effects. During normal sleep, slow waves are thought to help the brain reorganize and form new connections, a process called synaptic plasticity. If 5-MeO DMT creates similar slow waves while you're conscious, it might explain why people report lasting change in perspective and mental health after the psychedelic experience. The brain might be getting a chance to rewire itself in ways that normally only happen during sleep. What fascinates me most is how this research challenges our understanding of consciousness. We used to think that wake and sleep are completely separate states. But psychedelics show us that consciousness exists on a spectrum, with fascinating hybrid states in between sleep and wake. The fact that our brains can simultaneously be awake and asleep suggests consciousness is far more flexible than we imagined. Psychedelics may be the tool to access these simultaneous states and to uncover even more surprises on how our brains create reality. The book of the week. This week I read Rejection by Tony Talalamute. I give it 3 out of 5 stars. Rejection is a sharp, uncomfortable, and weirdly hilarious explanation of what happens when people desperately seek connection and keep missing the mark. Through 7 interconnected stories, Tony examines characters who are painfully online, chronically overthinking, and catastrophically bad at human relationships. Warning, this book will make you cringe hard. You might recognize yourself in some of these characters' worst moments, and you also might find yourself hoping that these characters just don't take it too far. Pick it up for a laugh or a cringe. Check this out. A viral tweet has circulated the internet, which shows the most detailed image of a human cell created to date. But that's not correct. It's not an image taken by a microscope at all, but it's a digital representation. It's a representation of an animal cell, not a human cell. So 2 things that we had to fact check there. And I came across it on my Instagram last week with the claim that it's the most detailed image of the human cell, and I thought it was amazing. But when I dug into it, I discovered the misinformation. And even worse, when the image gets shared, the original credit gets lost. Nonetheless, it's very spectacular and impressive. It's a stunning 3D computer illustration and Evan Igersol. It depicts a eukaryotic cell, which is an animal cell. And McGill explained to Newsweek for the article, Fact Check, does this viral tweet show the most detailed image of a human cell, that a real photo at this scale would just be physically impossible. In reality, molecules are smaller than a wavelength of visible light itself. The digital representation that they created synthesizes structural data from labs worldwide to visualize the great complexity and beauty of a cell's molecular choreography. McGill notes that the illustration actually shows cells are less crowded than what they really are in nature. All that being said, this image tends to circulate the internet from time to time again. If you want to check out the original source of the digital representation, you can explore an interactive illustration on Digizyme's website, which I'll link in the show notes, where you can highlight individual cell components to learn what they're called. Thanks for watching and listening to Nina's Notes number 133. If you like this episode, click the share button and send it to a friend. Don't forget to subscribe to my channel and my newsletter at ninasnotes.xyz, and I'll see you next week.